Hi everyone, welcome to episode 6 of the Signal and the Noise Large Language Model course. Episode 6 is the deterministic bridge, or bridging the gap between messy human intent and rigid code execution. In this session, we're going to go from active to reliable. An AI that can act is not yet useful. It must be integrated into other systems to reach its full potential. I think we've all experienced a chatbot, where we wish it could do something with it rather than having to copy and paste. That is very much the surface level of large language models. We've shown in previous sessions how to move from chat to persona and then to agent, and now we're going to look at production. Capability is impressive, but reliability is deployable. Part 1. The interface gap. Chatbots feel intuitive and powerful, but they are a terrible interface for automation. Autonomous systems must be repeatable, transferable, falsifiable, and ideally platform agnostic. Chat is great for humans, but software needs structure. Chat is ambiguous and open-ended. Software systems have different requirements. A good software system needs its inputs to be deterministic, structured, and machine-readable. After all, the plural of personal experience is not a peer-reviewed journal article. Open-ended inputs fail non-expert users. They're faced with the question, what is possible and what is safe? And this leads to prompt anxiety and inconsistency and over-reliance on AI tools. Freedom feels powerful until you need the consistency, and business systems are based on consistency. Structured inputs empower non-expert users. The inputs are sanitized and help is documented. This becomes confidence, consistency, and empowerment. A well-designed input form beats an open-ended chat interface for almost all production users. Structured outputs are the beginning of a pipeline. If it can't go in a database, it's not automation. A paragraph is great for humans, but useless for machines. Essays are a black box. They can't be queried, they can't be systematically stored, and they can't be pipelined into an API. Formatting is nice, but structure is the only way to scale. The trap versus the reality. The paragraph looks nice, but what broke? Who complained? And what is the next action? Paragraphs as outputs from systems are dead end. They still need a human to read it. This is not automation. This is just arguably faster reading. Although faster reading from a large language model may end up with more time being spent by a human at the end anyway. I'm going to do a quick introduction to JSON. JSON is JavaScript object notation. It's a format for structuring data. It's lightweight, it's human readable, and it underpins a lot of modern databases, for example, Microsoft Azure Cosmos DB. It's perfect for storing and exchanging data, and it uses a key value pair structure. We won't do a deep dive into JSON, but since it's something I'll mention from time to time, it's useful to know the basics for illustrating examples. Here are a couple of examples of how JSON looks in its raw form. You have a key and a value. So, for example, in the HR resume as JSON, you might have a candidate year's experience, and then the value would be 5. And then you'd have their skills would be a list of Python and management, for example. You can store dates and times, you can store numbers, you can store strings, you can store lists, you can store other JSON structures as values as well. Clearly human readable, which means it's tokenizable, which is great for large language models. We treat the AI as a universal adapter. It changes the messy world into a database structure. For example, an input, I need 500 units of the red widget SKU99-A delivered by Tuesday. The assistant says, sure, I see your order, whereas the agent can structure it into JSON. It now knows the requester because it got your email, it knows your count, it knows your SKU, it knows your deadline. This is the fork in the road moment. The same intelligence can produce significantly different results depending on how you implement the agent versus the assistant. The golden rule, we mentioned it before. If it can't go in a database, it's not automation. The JSON structure we showed on the last slide can go into a database. The response from the assistant could go into a database, but it's completely useless in there. Ask yourself the following questions. Can I pipe this straight into Excel without extra steps? If I ran this 1,000 times, would I have one file or 1,000 documents to read? If the answer is documents, you're still prompt engineering. You're not system designing. Most AI projects do not result in improved efficiency because they do not follow the golden rule. Prompt engineering is not the same as software engineering. Prompting only saves you time if you don't need to read the output. I'll repeat that. Prompting only saves you time if you don't need to read the output. The magic of AI is often a distraction from the utility of AI. Simply writing neat prompts will not save you time or money, but systems engineering will. The best systems do not look like AI. Chat interfaces force a user to type a request, wait for a response, read the response, and decide what to do next. This can have a high cognitive load with limited time savings. You've got the same problems, but you've got extra steps. Not only is this not saving time, it may actually be costing time. You've invested a lot in your large language model system. You don't want it to make your systems worse. Users don't want to have a conversation, they want a result. This shift is away from AI as a consultant to AI as an actuator. AI as a consultant still has a place, but it's not in systems design. The future is not talking to computers. Writing, reading, and talking is slow. Automation should be fast. Automation must be fast. AI is smart glue. It's the god of the gaps. If your large language model outputs data, it can be injected into the workflow before the user ever sees it. This can lead to smart defaults, silent classification, and contextual autocomplete. The ultimate success of systems engineering with AI is when the user forgets it is even there. The user should think the software is magic, or at least that they are just being really productive. I reduced my time to report value by 90% by hiding a super prompt behind a generate report button. The user should not prompt the model directly. The engineer should build the prompts ahead of time. The user just needs to interface with them in a simple and intuitive way. We need to stop building company GPT and build intelligent features instead. Whilst a fine-tuned model that's specific to your company's needs and with your institutional knowledge may be useful in some cases, this is not high-level systems design. Company GPT is centralized, prompt-based, and to a certain extent generic, at least generic within your context, within your company context. But intelligent features are embedded, scoped, and purpose-built. Chatbots can distract, but products improve productivity. Part 2. The speaking machine. Machines run on rigidity, and humans run on messiness. The machine needs an exact date and time, but the human understands next Tuesday-ish. An LLM system can become that interface. Integration starts where the English ends. Humans understand text or words or intent. Programs understand JSON. Large language models deal with both. Human integration with systems requires a deterministic format with explicit keys and predictable data types. Human text goes to a large language model, which outputs a JSON, which can be understood by the system. Machines do not just read text, they transpile or they translate and compile its intent into syntax. The language becomes the source code. The JSON becomes a compiled binary. The language, I hate this product, it broke immediately, becomes the JSON with sentiment between -1 and 1 potentially, and the tags. So in this case, negative sentiment because of hardware failure. The language becomes the source code and the JSON becomes the binary. Constraint is power, schema version. A schema does to output what a persona does to thought. It collapses the probability space into a specific schema shape with less ambiguity, fewer hallucinations, and hence more consistency. Extract the data becomes extract this exact structure. Creativity is optional, structure is not. A schema is a contract, not a suggestion. A schema does the following. It defines what's allowed, it defines what's missing, and it defines what's null. A null value is better than a hallucinated value. It also prevents the following. guessing, fabrication, and format drift. If the model must guess, then the system has failed. We would prefer to have a null than a hallucination. Modern models can be constrained at the token level. Structured output modes enforce valid syntax, and they reduce formatting errors. This is systems engineering, not prompt engineering. This is enforcement, not trust. Token streams are constrained to braces, for example, and keys. Hope is not a validation strategy. It is, however, important not to lobotomize a large language model. Forcing too much structure can strip the LLM of its ability to think out loud. Reduced reasoning can result in poorer quality outputs, so adding a reasoning key to the output schema can reduce the lobotomization. We saw this in the anatomy of the super prompt, where we include our model thinking within thinking brackets. The same principle applies here. Give the large language model a thinking scratchpad within the output schema. This can improve downstream auditing and validation as well. We have a direct line to the model's stream of thought now rather than just an output, but the stream of thought is structured and constrained and usable by downstream systems too. So don't just structure the output, structure the thought process as well. Whilst large language models can force the schema, they may still create bad data within this schema. Large language models ensure that the brackets match, but validators make sure that the data makes sense. For example, validators such as Zod or Pydantic may be used. The LLM offers a powerful opportunity to embed deep structure into outputs. For example, a sentence like Bob leads sales and Alice from engineering are meeting with Charlie from Acme Limited. The sentence becomes structured. We see the internal attendees and the external attendees. We have their names and we have their departments and we have their companies. We discussed earlier how JSON can nest itself within other JSON. This is an example of how deeper structure can be derived from a relatively simple sentence. The AI can understand the relationships, not just the words. Syntax is not truth. Valid JSON is not the same as valid data. We should not simply trust the LLM because the system did not crash. We can build in validation layers into our systems to ensure that the data is correct. The LLM may generate, but the code must validate. And if the data is not perfect, it must not touch the database. This shift in thinking moves us away from outputs and towards interoperability. Modern models are designed with this in mind, for example, OpenAI's function calling. But we need to move from prompt engineering to constraint satisfaction. The error rate needs to go from occasional to negligible. We need our loops to function unattended and still be safe. Outputs need to be reliably piped downstream to other systems. We don't just trust the model to behave. We engineer its environment so it has no choice. Part 3. The immune system. Reliability is an active process, not a static state. The large language model creates a hypothesis, but the code verifies the facts. Structure is not truth. The JSON can be perfect but factually impossible. For example, age is over 150. We still require a logical process that ensures the data does not violate business rules. Reliability is built, it is not requested. In a self-correcting system, the error message is the next prompt. The large language model outputs bad data. For example, age equals 20. 20 is not a whole number. The system catches the error and feeds it back to the model. The model retries and outputs age equals 20, the number 20, not the word. The model learns from the system in real time. A system that fixes its own mistakes appears flawless to the end user. The retry budget, because infinite loops are worse than errors. Every iteration costs time and money. We should set a limit on the number of retries. Often this is 3, although testing may determine that a different number is required in your system. Once the retry budget has been exhausted, the system must fail gracefully. Engineering is the art of managing fail states. The sanitizer. Models are expensive and many errors can be fixed with code. Code is cheaper than intelligence. Fixing standard errors using code is cheaper and more efficient than iterating using a large language model loop. Apply basic sanitization checks before an expensive model is rerun. Debris is caught instantly, but complex issues are sent to the large language model. Don't use a supercomputer to fix a typo. However, a self-healing system can hide a dying prompt. If your system fixes 50% of the errors, your user still sees 100% success. Monitoring the retry rate is critical for creating successful systems. A 0% retry rate has a perfect prompt, a 5% retry rate has an acceptable prompt, and a 50% retry rate may have an unacceptable prompt. Your prompt may be broken even if the output is perfect. We need to go back, check, and improve our prompts where appropriate. Success hides problems. Log your errors even if you fix them automatically. Users don't experience models, they experience systems. Reliability emerges from constraints, validations, and retry logic. Reliability does not emerge from smarter prompts or bigger models. Models guess, but the system decides. Part 4. Generative user experience. The interface is the bottleneck. Humans have had to adapt to interfaces for decades. Generative systems can now allow interfaces to adapt to humans. Traditional software means one correct way to do things, but AI can change what is possible if we allow structures to define presentation. Pick the right menu becomes say what you want. The biggest limitation in modern software is not the intelligence, but the interface. Text is a great thinking medium, but is a horrible user interface. Text requires reading, interpretation, decision-making, and text is ambiguous, hard to understand at a glance, and difficult to scale. If a user has to read carefully, then the system is unfinished. When an AI outputs text, the human becomes the parser. This is slow, error-prone, and unscalable. The cure may be worse than the disease. Once AI can output structure, the interface becomes flexible. The same result can appear in many different ways. The user intent becomes structured results, becomes optimized representation from a menu of different options. Maybe a dashboard, maybe a table, maybe a chart, maybe a form, or maybe a checklist. Structures allow the software to choose how to speak back. The same question does not always require the same answer format. Traditional large language model response may be a paragraph of text, but a generative user experience response can be a chart, a table, or a breakdown by region. The intelligence hasn't changed, the presentation layer has. The presentation layer has created a user experience shift from explanation to insight, from reading to seeing, from decoding to intuition, and from passing to acting. Insight beats explanation at the end of the day. The AI does not create the interface, it selects from known patterns. This is not AI creativity, it's AI classification. The AI asks, would this be better shown as a list, or shown as a chart, or shown as a form, and so on. This is safe, predictable, testable, and brand consistent. Generative user experience is adaptive, not artistic. We do not want to allow the AI to write the code directly. Directly generated user interface results in hallucinations, broken websites, and potential security risks. The AI should be selecting from pre-written options, pixel-perfect solutions every time, because the code was written by a human. The AI just selects the best option for the circumstances. Again, generative user experience is adaptive, not artistic. Whilst we can be optimistic, waiting 3 seconds for an output still feels sluggish in 2026. The latency issue is a common issue with structured outputs. We can generate a skeleton outline before the data arrives. So a request becomes a skeleton loader, becomes a finished output. We don't want to wait for the text to finish. We can build the frame immediately. From chatbots to widgets, from conversations to components. We move from one chat window to multiple small and purpose-built interaction surfaces. You may have noticed these popping up in Gmail recently. These have clear scope and expectation and have lower cognitive load on the user. These may be generate a report, summarize key findings, extract key fields. The future of AI is not one assistant, it's many small helpers. When the interface adapts to the task, it feels smart, even if nothing smart happened. The system might switch from text to chart, switch from summary to checklist, or switch from explanation to confirmation. This isn't artificial consciousness, it's good interface design, and it's powered by structured outputs. From the user's perspective, it feels like the system understood what they needed, and it gave it to them quickly and intuitively. Good interfaces create calibrated trust, not blind faith. The text outputs from traditional large language models encourage authority projection, they encourage overtrust, and the user feels that it sounded so confident it must be right. Visualized outputs encourage inspection, comparison, and sanity checking. A chart encourages scrutiny, but a paragraph invites belief. The best generative user experience feels like normal software, just better. No anthropomorphized language, no thinking, no dramatic answers leads to helpful workflows, cleaner workflows, faster workflows. And from a user's point of view, the user adopts training faster, the user adopts tools faster, less training is required, and less fear and resistance to the new systems. Adoption follows familiarity, not amazement. The future of AI is not talking machines, it's machines that quietly know when and how to respond. The user interacts with the adaptive interface. The AI gives you structure, options, and representations. But the human is still in control, in context, and accountable. We must never hand over accountability to an AI completely.